Feel Good Hemp is the first and only brand to offer high-quality CBD oil products alongside a free platform that offers proven self-help and self-healing techniques, all to help you feel good naturally. Feel Good Hemp was started by Noah and his wife Danielle after they used hemp oil and other techniques to save Noah's father from a terminal cancer diagnosis. Now, I heard this story firsthand when I interviewed Noah. It's a real good one, and it's probably the most heartfelt and compelling story I've ever heard about why someone started a CBD company. So Feel Good Hemp is more than just a great place to buy CBD products. It's actually a community of like-minded souls committed to feeling good and doing good. So use coupon code GENIUS33 at checkout to save a third or 33% site-wide on your first purchase. Visit feelgoodhemp.org to shop now and access their free empowerment platform.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Aydogan Ozcan. He's what's called the Chancellor's Professor and HHMI Professor. We're going to be talking about virtual histology. So I guess looking at the condition of tissues virtually and not, all in person. But we'll get into the details shortly. So thanks for coming. How you doing?
Doing great. How about you?
Good. Well, tell me about your background. How did you get into this area of work? And then I want to ask you about your current work.
Sure. So by training, I'm an engineer. I studied electrical engineering. And after my PhD, I moved into biomedical applications of engineering, specifically the use of light, optics, photonics, and how it can be used for microscopy, for imaging samples, all the way from very small things like viruses to bigger scale features of tissue, organs. So I'm interested in general applications of light for biomedical studies, diagnostics, pathology. And this recent work that you were referring to is around the use of AI machine learning on improving imaging microscopy in pathology, and specifically virtual staining. If you want, I can expand what virtual staining means because some of our listeners might not be aware of essentially what it means.
Well, all right. I don't know if they're aware of histology itself. What is it? How's it used? How is it currently done? What's it used for?
Well, almost anyone at some point will give a biopsy, right? So basically, to understand disease, to diagnose disease, we give biopsies routinely. A biopsy is a chunk of tissue taken from body. What happens to that tissue in a lab is not very commonly understood by patients. So it's good to understand that. So that tissue is thin section, meaning that imagine a tiny chunk of tissue which is cut into very thin layers, as thin as approximately 1/1,000,000th of a meter. So very thin slices are put on a glass slide. And if you take that thin section of tissue to understand disease processes at the subcellular, cellular level, you need to look under a microscope to see those small-scale features at the micron level, at the level of, again, 1/1,000,000th of a meter. You can't see them because thin sections of tissue are transparent. That's the reason why for the last century, in fact, more than a century, medicine and diagnosticians have been using literally dyes to color the tissue under a microscope so that those features of disease or healthy state of tissue can show contrast for diagnosticians to evaluate. All forms of cancer.
Yeah, one quick question here. So you said a thin enough slice of tissue is transparent. Is that 1 cell thick? And why is it transparent? Is it because the features of the tissue are sub-visible light dimensions?
So at that scale, the tissue becomes basically like glass because it's so thin that it does not absorb or scatter light enough for it to reveal. Of course, you cannot see through thick tissue, right? But when you cut it so thin to be able to look at a different cross-section within the bulk of tissue, it becomes like glass because it does not absorb light enough or scatter light enough. And that's the reason why traditional light microscopy needed, as I said, for the last century plus, dyes to show different features of tissue and subcellular features to be painted, so to speak. And under a microscope, it becomes a colorful image for diagnosticians to basically assess the state of tissue.
Is there a name for the transition thickness zone between opacity and transparency? And is that useful if you're somehow able to selectively slice tissue at just the right thickness so that it's not opaque, but it's not transparent?
So tissue, when it becomes more than several tens of microns, it starts to scatter light, and anything that is, let's say, more than a few hundred microns thick would be blocking and absorbing light. So, but traditional way to look at features clearly is not to section it into thick tissue like that. It's actually very thin, typically under 10 microns, a few microns thick traditionally, so that you can actually see features clearly, and with the help of stains, with the help of these dyes, these features are visible to diagnosticians under a microscope. So this process, as I said, is what's happening for the last century, but this is a laborious process. Literally, a histotechnologist is doing this staining, and depending on the tissue and stain combination, this process takes quite a while, a few hours, sometimes more than a day, depending on, again, tissue stain combination. So my work at UCLA used AI to change this staining process to be label-free, dye-free, meaning that most of the work of the histotechnologists, when they process a biopsy, is staining, actually using chromophores, dyes to stain. We replace that entire staining process with a neural network, with a convolutional neural network that basically looks at a native state of tissue without any dyes, without any staining process, and takes an image of the tissue using an autofluorescence or fluorescence microscope. What that means is, instead of using basically dyes to stain the tissue, we take the same thin section that is transparent, we shine light to it, and in response to that light, the tissue actually, the native state of tissue, emits a different color of light. And this is called fluorescence, autofluorescence, in the sense that in itself, the tissue has some fluorophores embedded within itself that emits light, fluorescence light. So we take those fluorescence images of native tissue, that is thin section, and train a neural net that exactly mimics what the histotechnologist does to tissue. And by using numerous tissue samples, we train a neural net to replicate the same staining process, so that without actually putting toxic chemicals on the tissue sample of a biopsy, we can actually transform those label-free, stain-free images into images that are equivalent to biopsied and stained tissue, bypassing the entire process. So this is enabled by basically deep neural networks.
I understand the processing part, the AI processing part, but what about the actual measuring? How do you get, a tissue sample to fluoresce without tagging it? Are you hitting it with electrons of certain, energies, en masse and rastering over the surface and looking at the scattering or the emitted photons? Or like, how are you capturing this information even before the interpretation of it?
Supplementing with hemp CBD products is one of the best things you can do for your overall wellness or to improve conditions like chronic pain, sleep issues, anxiety or depression, or other conditions related to inflammation. Feel Good Hemp offers high-quality CBD oil products alongside a free platform of proven self-help and self-healing techniques, all to help you feel good naturally. They're offering our listeners a very generous 33% off their first purchase. Use the coupon code GENIUS33 at checkout, and you'll save 33%. Visit feelgoodhemp.org to shop now and access their free empowerment platform.
To create a autofluorescence image of unstained tissue, basically you take a standard microscope fluorescence microscope and shine visible light, something on the order of green to red, visible light. That light is exciting existing molecules within tissue, a soup of molecules based on, for example, which tissue you're looking at. Those are basically absorbing that visible light and emitting a light that is at a slightly shifted wavelength, at a slightly longer wavelength, and that wavelength gives us contrast so that we can see different features of tissue, not in color, not in the format that diagnosticians are accustomed to seeing, but in a grayscale format, black and white format, that you capture the intensity of autofluorescence light from different parts, different pixels of a tissue. And that is fed into a neural net that gives colorful images as if basically it's been stained. Think of it as this. You can take a black and white movie and you can color it, right? It's very much like that, except we're doing this at the microscale, at the tissue level, so that those black and white movies are referring to the autofluorescence images, microscopic autofluorescence images of label-free tissue, and the output images are what diagnosticians for the last century are accustomed to seeing in terms of when they send a biopsy to a lab, next day they get a certain stained image. And this time we get that instantaneously in the sense that as soon as we get the tissue into those thin slices, within a minute or two, you can actually get the virtually stained images ready for diagnosticians. That means the entire diagnostic workflow in a pathology lab, whenever you give your biopsy, becomes faster because you don't have to wait for these stains. Sometimes more than one stain is applied on the same tissue. Let's say, imagine there's a patient admitted to a hospital, organ transplant rejection potential case, right? What happens is you take a certain biopsy and then you stain it. You look at after a couple of hours, look at the images. And then depending on what the diagnostician sees, he or she might request additional stains to be performed on the same biopsy. That entire process is a couple of days. So now all of that process is within the first 10 minutes that the diagnostician is looking at the case would be available. So it means faster, and it's also cost effective because you're not using a human's time, as technologist's time. It becomes faster and cost effective. And very interestingly, you also eliminate a lot of toxic compounds. All of those stains are actually quite toxic, and they generate quite a bit of wastewater, millions of liters of wastewater that are being generated through the actual staining process. So you also make the entire histopathology workflow, the biopsy processing workflow, environmentally much more friendly through a virtual staining process.
Well, I would think that you're also racing against the clock. If it's biological tissue, it's going to start dying and decaying. So if you're able to get this info in minutes and capture it instead of hours, even if the dye slows or stops the decay process, I would think this would be much more robust, and you could see much closer to what the actual living tissue did.
So since tissue is fixed, it's preserved well, it doesn't decay. You can actually store a biopsy and retrieve it and stain it even months after it's biopsied. So a lot of research, actually pharma-related research, sometimes use existing biopsied samples taken months ago from the patient for staining purposes. So from that perspective, there's no problem. But from the perspective of retrieving the diagnostician's report and giving the final diagnosis back to the patient as soon as possible, saving lives and potentially avoiding, for example, unnecessary hospitalizations, etc., that's actually time is of the essence. And the other very interesting thing that patients might not fully understand is a lot of times patients give unnecessary biopsy. The reason is this: every single actual staining process for a diagnostician to look at tissue under a microscope traditionally is a destructive process. You take tissue, slice it, and paint it, and it's gone. It's wasted tissue. You destroy tissue by that staining process. And if you need another analysis done on the same piece of tissue, you take another slice. that's the reason why quite a bit of patients have to give another biopsy, because the diagnosticians, through that process of investigation, they deplete tissue. They need more tissue. With virtual staining, by replacing those toxic chemicals with neural networks, we're also preserving tissue. That means you don't have to have unnecessary biopsies. You can actually preserve tissue, save tissue, and do multiplexed analysis on the same label-free autofluorescence image. Multiplex means, for the first time, actually, you can have different types of stains, dyes, performed on the same cross-section for the first time, basically. Because every time the diagnostician wants a different stain to look at a different condition, it's coming from another part of the tissue. It cannot come from the same section, because that section has been used for another stain. And that's where it gets even better than the current workflow in histopathology and processing of biopsies, because we can do multiplex stains on demand. Imagine the example between Blockbuster and Netflix. If you were to go to a Blockbuster, if you're old enough to remember those days, you would get a single CD or a cassette for a given movie. They were stored in those physical structures, cassettes, right? Tissue is like that today. Every patient's tissue is put on a glass slide and stored like that. That's Blockbuster, and that's today's histopathology. Netflix changed the game, because on demand, you can have access to any movie you want, right? If you stop a movie and start a new one, you can do that. And that's an amazing game changer. And that's actually how virtual staining in digital pathology is going to change things from a Blockbuster to Netflix.
What does that mean? What does that mean? If you virtually reconstruct what a slice of tissue will look like, what are other ways that it can be done digitally that will show something different from the first method used?
So the analogy here is this. If you want a certain tissue sample that is stained with stain and then stain B, stain C, you have to go to today's histology lab and get glass physical tissue on it, put on a microscope and image. Stain A, a different glass slide. Stain B, a different glass slide. Stain C, a different glass slide, all of which needs to be imaged under a microscope. You go to the lab literally to get those physical glass slides, each of which, think of it as a movie in a cassette. Now, the Netflix version of digital pathology with virtual staining is like this. It's already stored. We have the autofluorescence images of tissue. If you are the diagnostician viewer, go to the console and ask for stain A, stain B, stain C, right? All of those are immediately retrieved from the same digital image without having any need for a cassette or going to the cassette store, the Blockbuster location near the street. So that's the game changer, because it enables the diagnostician on demand without having access to tissue or its glass tissue slide. You have access to infinitely many different stains if you want. There is that many stains.
What does that mean, though? What do the stains do, the different stains? What would you see in a given piece of tissue that you would see with one stain and not another?
So different stains bind to different tissue subconstituents. For example, you can start to look at one type of stain, let's say HNE, which is the stain that is commonly used for almost any analysis, including all kinds of cancers. Oftentimes, that's the faster stain that takes approximately 2 hours, let's say, to create one. But depending on the condition, diagnosticians would require additional spatial stains that highlight different parts of the tissue, different morphologies and different pathologies better than the other. And that's why they like to, depending on the sequence of the workflow, they like to complement a basic stain like HNE with additional spatial stains. Jones silver stain, PAS, Mason's. There are many, literally, there are hundreds of different kinds of stains that are used. Some of them are more frequently used than others. Some of them are less frequently used. But depending on the case, depending on what the diagnostician wants to see, different types of dyes, stains, would highlight different. On top
I guess
of that,
the good thing too is that for a given piece of tissue, you could, virtually stain it 100 different ways. You don't have to, like, I'm sure some of these are exclusive so that you stain a tissue with way 1, you cannot go back and do number 2. You'd have to use different but similar tissue. But this way you could use the exact same.
That's exactly the reason why it also eliminates wasting tissue or unnecessary biopsies. Exactly what the thing that you highlighted, where if you stain it with stain A, you cannot restain it, erase it, and then stain it with stain B. You have to take another slice of tissue from the same biopsy, and then again and again and again. And that depletes, that basically destroys tissue. So you have to call the patient again for an unnecessary biopsy. Now, with
it's not just that too. It's not just that. I could assume someone's liver tissue that I've biopsied, will be similar if I have to use another sample of it. But this is literally the same sample, so it would reduce variability because you're looking literally at the same tissue in different ways, not different tissue that's similar and hopefully the same.
That is true. So you can, within the same tissue, if you take different cross sections, there are different cross sections, but it's the same biopsy. And that's the traditional workflow, which means that tissue block represents the state of tissue. Different than this traditional workflow, on the same cross section, as I've highlighted a couple of minutes ago, on the same cross section, you can have multiple stains performed digitally, which is not possible today. If you want to perform multiple stains today, you're looking at the same tissue block but different cross sections, which still represents the state of the disease and gives you diagnostic accuracy. But for the first time, diagnosticians would be able to, with just changing one stain to another, look at exactly the same cross section of that tissue block with different kinds of stains. So that's something that today diagnosticians don't have as part of their training because they don't have that kind of a technology. Every other stain comes from another section within the same biopsy tissue block. So that essentially is another very exciting aspect.
Yeah, this is really cool. Have you guys gotten to the point where you've taken, again, 2 histological samples from the same tissue and looked at traditional staining versus, let's say, 30 different methods of your virtual staining, and then compared what you can see and what you learned about a tissue versus traditional methods? Like, what do you see what if you threw every staining method in the book at a particular tissue? What do you think you would see that would never normally be able to be seen?
Basically, we have tested the efficacy, the success of virtual staining technology with various different organs and stain combinations. And we've done blinded testing with diagnosticians. Basically, we've taken different cases, human tissue with different diseases, normal and different states of disease. And we've given diagnosticians, board-certified pathologists, a stream of images. Our images, virtually stained, mixed with standard histology workflow, standard histochemical staining of the same tissue corresponding to the same patients. They did not know which one is which. We asked them to evaluate the quality of the stains for different purposes, for different subcellular features and membrane quality, this and that, nuclear features. So we asked them to look at the quality of the stains without knowing which is which. Basically, we found that there is statistically no significant difference between our images and standard workflow in terms of stain quality from the perspective of diagnosticians. At another level, we also asked them to diagnose the condition of the patient. So we compared basically what kind of diagnosis they achieved with our images versus the standard workflow. And we also found that from their perspective, it's basically identical. They do not basically make mistakes with our images more than the mistakes that they make with standard. So it's essentially statistically identical in terms of the eyes of the diagnosticians, board-certified diagnosticians are concerned. We've done also other kinds of tests where it's kind of like a Turing test, like test where we've shown them images and asked them which one is histochemical stain and which one is fake, or which one is, having some artifacts that might be generated by another technique. In other words, we didn't tell them what is virtual staining, but we asked them, can you differentiate the real histochemical stained tissue from the other images? And basically, they cannot, 50% of the time. It's like flipping a coin. So basically, they cannot understand the difference between standard histochemical staining process versus ours. But of course, one of the most exciting parts that I see is repeatability. That I see with virtual staining, we have an enormous repeatability, consistency. You may be wondering why this is important, because in clinical workflow, you imagine this actual histochemical staining must be repeatable, right? It must be consistent every time. The reality is not. If you ask diagnosticians, they would tell you a lot of stories how sometimes they send a biopsy to a lab and what they get is really garbage. It's not usable for their diagnostic decisions. This happens quite often. What happens then? They send another request for another staining process. In some of the more exotic, difficult immunohistochemical staining processes, these are some of the staining processes that are more expensive and that take about 24 hours to create by a human. These are sometimes 30% of the time garbage. They cannot be used. How do I know this? Because in our comparisons, we were using basically state-of-the-art pathology labs as our ground truth, as our comparison basis, right? We take tissue of different kinds for different patients, and we apply our own virtual staining and then send the same label-free tissue to standard histopathology labs for them to do their magic and stain them to compare. When I get those images, 30% of the time, some of those more difficult stains come entirely garbage, artifacts of human processing. We eliminate those. And that's why virtual staining, in a sense, is symbiotic to diagnosticians. It's going to make their diagnosis faster, cost-effective, and more repeatable in the sense that it's not going to surprise them with poor quality, unacceptable stains. Because one of the best things about a neural net is that it's going to do the same thing because it's highly repeatable in what it's trained for.
So how would this become the standard? Even for starters, maybe this is done before staining as a quality control check that becomes required. And then in the future, no more staining. You just do this instead. What do you think that evolution is going to look like, and what will it take for labs en masse to switch to this?
So I think virtual staining will impact many different areas of medicine. One of the first near-term impact that it's going to generate is actually drug development and pharmacology. Basically, any FDA-approved drug has to do toxicology testing, and these are done on animals. So one of the, I think, first immediate impact that virtual staining through autofluorescence of tissue will generate is to make those drug development related animal research and toxicology studies to be virtually performed. This is something that I think we have data that shows animals' tissue staining is also working beautifully well. Just like humans, animals' tissue also autofluoresces, and in a consistent manner, it helps us replace those standard workflow that a pharma company has to go through the FDA process, has to generate those toxicology reports. They can be made using virtual staining faster with preservation of tissue. Imagine a small mouse, right? Some of the organs are tiny. So it would perhaps be faster and preserving tissue and making maybe the use of less animals and potentially accelerate the approval process of some of the drugs through virtual staining. Also making it faster and more cost-effective to generate those data. I think pharmacology and generation of toxicology reports for different drugs would be one of the most exciting aspects of virtual staining. In addition to this, I think teleconsultation, telepathology services. Imagine you have a primary diagnosis made with standard workflow. Standard histology workflow generated a certain diagnosis. Oftentimes, there is a second opinion requested. A lot of the US diagnosticians actually work with overseas hospitals and insurance systems to give second opinion. They do not see the patient. They just see digital images of slides, biopsy slides. So those kinds of situations where you ask for second opinion in addition to standard workflow would be another, I think, easier to handle case because second opinion means there is already a standard workflow that generated the primary diagnosis, and this is essentially a second confirmatory analysis. And that's going to actually help telepathology reach to even remotest parts of the world, because you don't need histology labs, advanced histology labs with all the workflow, all the stain quality matrix, etc. One of the biggest issues that we see today is, even in the United States, histology labs suffer from supply chain issues and repeatability issues. What I mean by supply chain is most of those actual toxic stains come from a few countries in the world, such as India. During COVID-19, what did we learn? Supply chain failed. What does that mean for histology? Those stains and the quality of those stains would be widely varying during COVID-19 or other situations like this, where supply chain is hurt. So as a result, you don't have to worry about those toxic chemicals, their quality, and the quality of these technologists, which is hard to find in different parts of the world, right? They cannot prepare the tissue right for telepathology to kick in. But with virtual staining technology, I think the reach of telepathology services for second opinion would be drastically increased, helping us to democratize basically access to advanced pathology and diagnostics through histology.
Last question for now. What cost versus traditional methods? What does that look like so far, or are you not there yet?
The cost is on the order of, so the cost basically is just consumption of energy in a GPU. Basically, even using expensive cloud-based AWS servers, it's going to be negligible, on the order of cents per slide, as opposed to basically several dollars to in some cases tens of dollars per slide. So because the current workflow involves toxic chemicals, waste of energy, waste of water, it's a very laborious and extensive process. It also involves human time, humanist technologist time. That's why it's costly. With our virtual staining, that cost will be the differential cost that we will add by taking out all of these will be replaced with just basically GPU time that you spend. And per slide, for a whole slide that's put on a glass slide, we can virtually stain it in about a minute or two, depending on the tissue area. 1 to 2 minutes of GPU time. That's essentially the cost of it.
Yeah, this is amazing. This technology sounds really cool. What's the best way for people to learn more about it? And if anyone's listening that works in a lab or uses a lab frequently, how do they let the lab know that this technology is either available or soon will be?
So obviously, this is research coming out of a university. So it's not FDA approved for primary diagnosis. There's a startup company that we established in Los Angeles that is that's commercializing this virtual staining technology. Its name is Pictor Labs. Pictor in Latin means painter. So basically, we're painting tissue, microstructure of tissue. So, and we are heavily moving forward to streamline this so that it could be used by, first of all, researchers. There's a lot of cancer-related research or other types of neuroscience-related research, cancer-related research that routinely uses stains for animals, for human tissue, anything. So, first of all, we believe that virtual staining workflow, will tremendously help researchers to advance their research progress to be better, faster, enable new biomarker discoveries, etc. And in addition to this, I think we have made some great progress to apply this technology to animal tissue, and some of the companies that are working with pharma companies to help their FDA process are also extremely excited to replace their current workflow to be digital and virtual staining based. So I think to look at the state of the art of virtual staining coming from our lab, they can look at Pictor Labs website to understand where it is right now and where we're pushing it.
Very good. Well, thank you for coming on the podcast. And like I said, it's really, really, really cool what you're working on. I think it's going to be a huge game changer. And again, thank you for being here.
Thanks for the opportunity. It was great talking with you.
Remember, before you go, supplementing with hemp CBD products is one of the best things you can do for your well-being. Get your CBD from a company that cares and offers you holistic support in your healing or wellness journey. Feel Good Hemp is giving our listeners 33% off their first purchase. You can use coupon code GENIUS33 at checkout to save 33% site-wide. Visit feelgoodhemp.org to shop now and access their free empowerment platform.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.